Greetings everyone. Welcome back to part 3 of 3D printing on our NPTEL lecture Microsensors Implantable Device and Rodent Surgeries for Biomedical Applications. In the past two lectures we have discussed about different kind of 3D printing technique, what all ways different 3D printing techniques differ from one another, which all things we can use for something related to our specific applications and all. So in this lecture we will be discussing about how to make a 3D model. In the past lectures we have discussed what are the different ways of making a 3D model. That is, one is STL, direct scanning. Another is making a file from base itself, making a file from scratch itself, because making something from in a 3D modeling software and converting into an STL file and using it for 3D printing. Another one is photo scanning. So there are different methods of making a 3D model. So in this lecture we will be specifying on, or we will be focusing on how to make a 3D model from a 3D modeling software. So here we will be discussing about SolidWorks, how to use SolidWorks, what all its features, or how to I will just give you an introduction about how to start designing something on a SolidWorks software. I hope you can see my screen. So when you open SolidWorks software, which is actually a paid one, so once you open a SolidWorks software, this will be the screen available for us. So the specific software I am using is SolidWorks 2021, but even if we are using 2017 or 2013, there will be slight variation on how the layout will be looking like, but almost every features will be same in every systems, so that you can compare with one or another versions of software. So this will be the screen that will be available once you start or once you open the SolidWorks software. So first you need to go to file option here, and in file option you need to select new. Once you open new, then this will be the three options available to us. So the first one will be the part option, where we used to create a single part in a single 3D model or a single 2D sketch, whatever it may be. Then you will be having an assembly option. So in assembly option we will be clubbing together multiple parts together, and then we will be making an assembly. Okay, so then you will be having a drawing option, where once we created a 3D model, we need to create 2D sketches of that model. So we will be using this option, sorry. And then out of this, currently we are going to use part option. So first we will try to design a 3D printable keychain. Okay, so first I am selecting this part option, then I am clicking OK here. So this will be the window available to us. You can see a tons of option or tons of keys here, so don't bother about that. Here I will take you to some of the most important options, so you can just start in 3D modeling. So once you go to here, you can see Feature Manager tree, and then here you can see Property Manager, then there will be Configuration Manager, then there will be Digsumperf Manager, then there will be Display Manager. So here we will be mostly using Feature Manager and Property Manager. On top you will be having Features, Sketch, Surface, Sheet Metal, Markup, Evaluate, and some embedded dimensions and all. So mostly we will be concentrating on features and sketches. So in I will just tell you one thing, like if you need to add something that is not visible in this tab, you can always right click to any of these buttons, and then there will be options like tabs. So just select tabs feature, and suppose I need a weldment feature to be there, so I can just select weldments here. Okay, so we will be able to see weldments option here. So even if you now I don't need weldments and my tab is busy, overcrowded here, so the same I can do, right click on any of this feature, click tab, and then you can just unselect weldments. So that's how we will add or delete option from our feature manager. So first the base of a 3D sketch is always a 2D sketch. So first we will be start by designing a 2D outline of what we need to create. Okay, so once we go to the feature manager, you will be able to see annotation, materials, plane, and different planes, because we can use these three planes to start building our 3D model, and we have an option to add unlimited number of planes in our sketches itself. That is a little bit of complicated topic that will be discussed later. So first I will select this front plane to start my sketch with. So I will right click on this plane, and then there is an option on a sketch. So once I select the sketch option, then SolidWorks will automatically make my front plane to start sketching with. Okay, so this is the plane. That means front plane is the plane that I am using to start my sketch with. So first I will try to make an rectangle, and from that rectangle I will try building new features features on that rectangle. Okay, so here in the sketch option you will be having different options like exit sketch or make sketch, and smart dimension. Then these are the tools that we use to draw our shapes. Okay, since I am going to make a rectangle, I will be selecting this rectangle option. So once you select the tool, once you use select which tool you need to use it, then this property manager will be open, and here you have an option to make different kind of rectangles. Okay, so this particular rectangle is used for making, like used to make rectangle with 2 points, means with 2 corners. This one we used to make a rectangle with one point at the center and 1 point at the corner, and this with 3 points, 3 corner points, like that. You have different option. For now I will select this option with center rectangle. So once I select this, and this is the plane, or this is the work area where we used to create our model. So in this work area I will be selecting this is the origin point. Okay, this is the origin point which is actually fixed by the software itself. So once I came near to this point, we can see that our pen tool getting locked to that origin point, and I will just right click here, and then I will just move my mouse so I can make a rectangle in whatever shapes I want. So I will try to make something like this, and then again I will click my left button, so a rectangle is created. But now you can see that the rectangle is made up of blue lines. Okay, blue lines indicates that rectangle is underdefined, means it's we haven't given complete dimension to my rectangle, to our rectangle. So since it's not completely defined, it will be having a blue color, and this dark blue shaded area means it's a closed figure. Okay, so if I make something like C, we can see this doesn't have this kind of dark or shaded blue region. This means the shape is open. Okay, so I will just simply delete it. How to delete it? If you want to delete it, you can just select the entire portion. Once you select the entire portion, you will be changing the line color from dark blue to light blue, and then just press delete option, so that shape will be deleted. Okay, so now I need to define it, means now I need to give dimension like how much length my rectangle should have, how much breadth it should have. In order to do that, we have a smart dimension tool. Smart dimension tool is usually used to give dimension like length, angle, and everything. So it will be automatically detect what kind of dimension we need to give, and it will give the figure the required dimension. Okay, so I will select the smart dimension, and then just select this line, because this is the line that I need to initially give the dimension. So I will select this line, and then just keep this smart dimension here. So currently it's about 186 centimeter. Okay, 186.5 centimeter. Sorry, mm. So I need to give it around 50 mm. Okay, that means 5 centimeter. So I will type 50 in this dialog box, and then just press enter. So now this line will automatically become 50 mm in length. Now I need to give breadth. So in order to give breadth, I can either select this line, so it will come like this, and then if I press escape, then this selection will automatically delete it. And or else I can select this line, and then just this line, so it will again give the dimension of this line itself. Okay, breadth itself. So I then just press left click, then I would like to give it around 28 mm. So I press 28 and then I make a rectangle with 28 mm in length and 50 breadth and 50 mm in length. Now you can see that the outline of our rectangle changes to black color. Black means it's fully defined. Okay, blue means it's under defined, and black means our rectangle is now currently fully defined, means we have given whatever dimension we need to give to our rectangle. Okay, now I will show one more thing. Now I will make one more rectangle here, and then I will give this thing 10 mm, and here I will give 20 mm. Look, now even if I give 20 mm and 10 mm, the same dimension that I given to these figures, it's not fully defined, because earlier we developed our rectangle from the origin point, but here we doesn't have we don't have an origin point. So as you can see, just I am pressing escape to press escape to go out from the smart dimension, and then I can move this tool once with my mouse key, right? But here, even if I try to move, it won't move, cannot drag, because the selection is fixed. But here it's not like that. So I can actually make this figure or make this shape defined in reference to our master figure or the first figure. So I can just select the smart dimension again, and then I can give this thing around 10 mm in length and this thing around 15 mm in length. Now you can see this figure is also completely defined. So this is how we will be completely defining or giving dimension to our figure perfectly. So it will be aligned to one another, or it will be locked in position. So if we need to delete it, if I need to delete this and this thing only, means, or I will add a center line. Center line is actually just a construction line that we use to make some figure, so it doesn't have any direct influence on our shapes. Okay, so I will make a center line here, and if I need to delete only this half of the line, what will I do? If I need to delete this entire line, I can just click this entire line, selecting it, and press delete button. So it will delete the entire line. So but I only need to delete this half line. So you have an option called as trim entities. You can select that trim tool and then just drag on the portion where you need to delete. So once I drag on the portion, you can see that only half of this line is deleted, the remaining half is there itself. Okay, so now we can just get rid of the entire thing. So I will be just selecting this entire area. Sorry, this is delete trim entity itself. So I will be selecting this entire thing. Sorry, this is trim. I will be selecting the entire thing, press delete. So we only have this rectangle here. So here in this right side, you can see two buttons. One is exit sketch after saving. So if I click this button, this sketch will be saved and exited. But if I click this arrow mark, this is just an exit button, it won't save your sketch. So here I am exiting the sketch after saving it. So now you can see the sketch here. Now I need to make this 2D sketch into a 3D model. So I need to extrude this sketch. So for extruding the sketch, actually you need to select the sketch, then you need to go to Feature Manager or Feature option here, and then you will be having an option of Extrude Base. Okay, so select this option, and then now I am planning to give it for give an extrude extrude it for 5 mm. So just select 5 mm here in this option. In this depth option, you need to select 5 mm here, and then just press this, just click this button. So now you will be having a 3D block from a 2D sketch. Okay, this is how we will be building our 3D sketch or a 3D model from a 2D sketch. Okay, so now I need to have a line, I need to have a wordings like 3D printing here. So for that I need to make an extrusion of 3D printing text here in this face. Okay, so I will right click on this face and then I will start to sketch here. Okay, then I will make a center line here. Okay, then press escape to leave that line. Then here is an option known as text option, and I will click that text option, and here you will be having an option to write whatever you want. Now I will be writing 3D printing. So 3D printing is here. So if I need to change the font and increase the dimension of this font, then you can uncheck this use document font, and then just select this font option. And then if you need to change the font, you can slide through this font option available. I will be selecting this copper font, and I need to increase the font size a little bit, maybe some 4. Then select OK. So now you can see the font is changed as well as font size is also changed, but it's in somewhere. If I it's in like out of my box itself. So if I need to make it inside this box, I have a reference line here. So now I am selecting this reference line. Okay, now you can see this 3D printing is almost aligned to my reference line. Okay, so now I can exit the sketch by saving it. Now wherever I move my line, my reference line, my 3D printing text will be moving. So I will try to arrange this reference line almost in the same size of this 3D printing, but I need to make this line in center of my extruded box. So what will I do is that in this area, like I need to make center of this line, right? So I will select or right click here, and I will select the midpoint of this line, and then I will find the midpoint of our reference line, press Ctrl and select this line. Now a dialog box will be appear here, or here you can see the relationship, like what relation you need to add between these 2 points. Now I need to make it vertically aligned, so I will make vertically aligned. So center point of this reference line and center point of our main 3D model, main rectangle, will be aligned together, will be in a vertical plane. So now I will just put this up a little bit. So now I can see it's almost aligned, means the 3D printing is almost aligned to my aligned to center of my rectangular box. Now I need to extrude it up. So in order to extrude this 3D printing text, you can just go to Feature Manager, and here will be an option called as the same thing that we used earlier, extrude base. And now I am planning to give it a depth of around 2.5 mm. So you can see a preview of how it will be looking like, and if you are okay with it, then just press this OK button. So now you can see the 3D model, a 3D text model on our base. Okay, so but it's looking just really plain, so I will give a fillet to this edge. It will look more aesthetic. So in order to give a fillet here, you have multiple ways. One way is in the future option itself, you will be having a fillet option. Select this fillet option, and it will be in manual fillet option. Then just select the edges where you need to give a fillet. So here I select this edge, and it's giving a 10 mm fillet. Maybe I will reduce the fillet size to 5 mm or around 8 mm. And then I can select all the edges where I need to give a fillet. Okay, so then I will select this edge. So you can see the live preview there itself, this edge and this edge. Okay, so I'm happy with this fillet. Now I will be exiting this fillet after saving it. So you will be having a fillet 2 in your older rectangular base 3D model. Okay, now I will try to give a step here, so it will look more good. So again I need to have a step in this face. Okay, step from this face. So I will select this face, right click here, and then I press the sketch option. So now our sketch will be activated. You can see this, and now I can sketch anything only on this plane or on this surface. So for that, if I need to make a 3D model, I have a 2 option. Either I can use my sketch like line tool and arc tool to make the exact opposite same thing or exact replica as this thing, or else I can use something known as convert entities. What convert entities do is that it will replicate the same underlying feature. It can be 3D sketch, it can be a 3D model or anything. It will replicate the same underlying sketch. Okay, so I need to have an exact replica of this thing, this corner. So I will just select this surface and then I will select convert entity option. Okay, so you can see that exact this thing, exact the like borders of our base layer came to a sketch. Now I need to have a step, or I need to have a step of around 2 mm in width. So you can either build the same thing and give the dimension, or else since it's uniform I can offset this like sketch. So in order to offset, I have another tool known as offset entities. Select this offset entities, click on this thing. Since select chain option is present there, it will select the entire thing, or if it's not there then it will only select this line. So I am just enabling select chain, so it will select the entire thing. Now I need that thing to be around, now I need this offset to be around 2 mm, or give it as 2.5 itself. And then I need this offset to be inside this base thing, inside this rectangular base. So I will just select reverse. So now you can see that rectangular thing come inside our rectangle itself, the base rectangle itself. I am just saving it. So I am here having a closed loop, means this it like closed figure with 2 of this rectangular, or rectangular with filler thing. Okay, so now we will extrude this thing. So go to features, extrude base. So now the SolidWorks will automatically detect which thing I need to extrude, and then I can extrude the thing. You can see the preview here, but you can say that okay, here are 2 things to be extruded. Means you have one like one rectangle here, and one smaller rectangle. I am just calling it as rectangle for now. One smaller shape and one bigger shape. So why SolidWorks is not extruding both things? So you can do that. In order to do that, you have an option on a select contours, and just select this area too. Now only this area will be extruded, and if you need to extrude this area, you can just click that too. So you can see that both the areas are now having a 3D shape or extruding. So I will just cancel this thing. I only need this thing to be, means this area to be extruded. So I'm just selecting extrude base, and I have given 2.5 mm in height, then press OK. So now you can see a somewhat keychain like shape here. So for keychain I need to have an hole here also to put my metal ring. So that also I need to have in this same plane. You can select whichever plane you want, but now I am selecting this plane itself. So I am right clicking here, select this plane, and I am making a hole of around 4 mm in diameter. I am not fully defining it, just exit the small dimension by pressing escape. I am placing this circular thing here. Then in features, now I am going to extrude cut it. Extrude base means it's build up the object. Extrude cut means it will remove the object, or remove some part of like remove a shape from our base shape. So I am clicking extrude cut, and I am giving blind I am giving here a depth of around 10 mm or more than 5 mm or 3 mm, which is our base depth. So since our base depth is 5 mm, I am giving here a extrude cut depth of 5 mm. So you can see a hole here. Okay, so now to make it little bit more good looking, I am using a fillet option. Then I am just giving a fillet of around 1 mm here, and then a fillet of around in this corner, I am giving a fillet of around 0.5 mm, and then just press OK. So now we created a 3D printable keychain. So this is a 3D file which you can save in different format, like the base format, or the normal format in SolidWorks is solid part for a part file. So you can save the part file by file, save as. Now I will go to my desktop. Now I'm creating a new folder, nptel. Now here I will rename it as keychain, and solid part is the usual file format which we will be using for saving SolidWorks file. Okay, so I am clicking save. So now this format is saved. So if you want to 3D print it now, or then you need to save it in some kind of mesh file. You have mesh files like 3df, or you have a mesh file like STL. Usually we will be saving this file in STL format. So for saving this in STL format, you can again go to file, save as. Then here you can say which type you need to, you can select which type you need to save our file. So just click on solid parts, you will be having STL here. Okay, so just select STL. So earlier it was not 3df, it was 3mf. Okay, so STL, then click save. So now you will be having a preview like this. This is actually called as mesh file. So then just check yes. So now this file is actually saved as STL file as well as SolidWorks solid part file too. Okay, so this is how we will be creating a basic shape, basic part in SolidWorks. Now we will be seeing how to create a assembly model in SolidWorks. Okay, for example, now I need to give a cap to this 3D print this keychain. What will I do? I need to make an extra cap, so I can put this 3D printed file into that cap and I can close it like this. Okay, so we will be now making a cap for this thing. So for that I'll head to file, new, then I will create a new assembly here, and then just click OK. So you will be having a new window here. Okay, you will be having a new window exactly like the part file, but here you will be having some option like assembly, layout, sketch and all. So first you need to head to assembly, then you need to insert the earlier made keychain into this thing. So to make that, just click insert. Here itself you will be having that keychain option because we have just opened it. It's already opened the SolidWorks. Otherwise you can use browse option, and then you can head to whichever folder you have saved this thing, and then just import the solid part file. So just click on this keychain and then just click open, place it here. So now you will be having that assembly. So place it here. Now you will be having that keychain on your assembly window. So I will be making a small cover for this keychain. So to make that cover, I need to have a new part. So to make a new part, you can go to this insert component option, press this arrow, and then just press new part. Okay, so here I am going to rename it as keychain cover. Right click, just press here, right click here, then rename part. I am going to rename it as keychain cover. Okay, so after renaming it, press enter. Then you need to edit, you need to make a new part on this keychain cover part. So just right click here again, then you will be having tons of options here. Just go to edit part option. So press this edit part button. Now whatever you are making, that will automatically go to this keychain cover part. Okay, so I need to make a cover here. So to make a cover here, I will start with this face. So I need to make a cover that will come till this part. So I will select this part, press sketch here, sketch with this plane. So you can always press space key to change your orientation. So once you press space key, you will be having an orientation view like this, and just head to whatever place you need to go, whatever view you need to go, and then just press this kind of this window. So you will be having an orientation of that plane exclusively. So you will be having something kind of this, and you have already selected which plane you need to have you need to start your sketch from. Okay, so before starting the sketch I need to check the thickness of this plane to this plane. So how will we do that? Like smart dimension is actually used to give some dimension, but if I need to measure dimension from this plane to this plane, then I can go to evaluate window, and then here is an option called as measure. So select this measure option, then select this plane, and then just select this plane. So once you select both of this plane, you can see the distance here, this which is 7.5 mm, or else you can go to here is the measure dialog box, then you can see the distance here too, which is also 7.5 mm. So I know the maximum height is 7.5 mm. Okay, so now I will start sketching. As earlier, I will give an offset from this edge. So it will be like, select this face, go to sketch, offset entities, then I will give an offset to this place. I need to reverse it, but I need to only give an offset around 0.25 or 0.2 mm. So you might be thinking why I should give an offset. Instead I can just convert entity, means convert the same face, because since we are 3D printing it, we need to give a small offset, then only our two parts will mate each other. Okay, so offset depends upon which kind of printers you are using. Generally you can give an offset in the range of 0.1 mm to 0.3 mm depending upon which printer you are using. So currently I am giving a offset of 0.2 mm, so it will easily go in and it can easily come out. So I will select this face, then I will select this edge, then this edge. Likewise I will be selecting all of my edges. Okay, now it has become a closed loop, closed shape, but it's just like once I select entire edges, it just reverses direction. So I just unclick this reverse dialog box, so you can see that it go just out of my shape. Okay, so now I press OK. Now I need to have a wall. So in order to have a wall, again you need to offset it for 2 mm. Like now I am giving a wall thickness of 2 mm. So again click this offset button, click on this button, and then just select chain button, but I need to give an offset about 2 mm. So instead of 0.2, give here 2 mm. Okay, then just press OK. So now you will be having a wall kind of structure here. So now I need to extrude it to 7.5 mm. 7.5, but it extruded in the opposite direction. To change the direction, you can have an change direction arrow here or reverse direction arrow here. Just select this one, so it will reverse the direction. Okay, so this is how, this is now just a wall. Now if I now I need to have a top cap kind of thing. So top cap need to be in this face. So I will just select here this this plane, then just select sketch option, then exactly like I need to have an proper copy or proper replica of the outer edge. So I select this face completely, click on, or else click on convert entities, then I can select edge by edge. You can select either of way. You can just select this face, so it will like converts the outermost entity. So you can select like whatever edges. If I need this edge needed to be, if I need the inner edge need to be converted, so you can just select this inner edge, then I can just click OK. So you can see now this edge, like outer edge, and you can see a line here. Now I am doesn't need it, so I am just going to trim it, or you can even delete that thing too. So now you have a shape here. I'm going to again extrude it. I'm going to extrude it for around 2 mm. So now you are having a cap to your earlier built keychain. So I just done this to show how a assembly part can be made. This is a simple one, but SolidWorks is so powerful that you can create a highly complicated assembly feature inside this assembly part, assembly window or assembly option, and then you can check whether this thing work exactly like how we planned. So then only you need to go for manufacturing. So that's a major advantage of this assembly window. So you can make different part, you can bring those different parts to our assembly window, you can mate each other using the mate tool. means you can give the relationship towards like each surfaces, and then you can check whether this thing works as we planned or not, or since if it's having some kind of interference in some phases, then you can modify it and make it work perfectly as we planned. So this is a simple example. And then now to make it a little bit more beautiful, then I am giving a small fillet here, not just 1 mm fillet here. So now you have a complete keychain and a cover for that keychain. This just look like a box, but yeah. So if you need to save this shape, or if you need to open this like part as a only part file, now it's in assembly file, no? So if you need to save this as a part file, only just open this as a part file, and if you need to edit it, just right click here, and then you have an open part option. So just click on open part. So now you will be only having that part file. Now here also you can edit it whatever you want, that will reflect on your assembly file too. So I will just show that too. So if I need to have an like array of holes here, I will just select this face, and then I will put a small hole here. I will give a dimension of around 2 mm. So let this hole be here. Now I need to extrude it. I need to cut it. So this is how it will be. Suppose imagine if I need to give this hole through this entire line that can fixed distance of 2 mm. What should I do? I just need to make each circle as it is, but it's really a time consuming process. So SolidWorks has an option called as linear pattern. So you can select this linear pattern option, and then first you need to select which direction I need to have this hole patterned. So I will be selecting this this line as the direction. So you can see this arrow. So if I go to features and select this option, you can see now I have 2 holes, but I need to have at least 2 holes 10 mm apart, but I need to have holes 5 mm apart. Just I will put 5 here, and then I can increase the number of holes. So I will be having around 10 holes here, and suppose I need to have the same thing above also. So I will just select this direction of the direction 2 option here, and then in this direction I want. So I will just select this key here. This key here, and then I will be having one more, like around 5 mm apart. So I will be having one more. Then you can see the preview. If you are satisfied or okay with the preview, then press OK. So now you will be having a holes which is patterned. We only made one hole, and then we patterned this much hole. So that's why pattern is using. So then just click Ctrl S, because it's already saved in assembly. Then you can head back towards the assembly option here. You can see the changes that we done there actually reflected here also. So we are and now we are going to save this assembly. To save this assembly, go to File, Save As, and here we already created an option. Then keychain cover. Now it will be saving as a solid assembly format. Okay, now click Save. Just click this option. Now this assembly is entirely saved, but assembly is saved as a solid assembly file. If we need to 3D print it, we need to save this as an STL format. Either you can save the assembly as an STL format. It will create 2 separate files of these 2 separate parts and save, or else you can save this part individually. Like you can just open this part, then head to File, Save As. Here already we have created the keychain that we save the keychain that we already created. Now we need to save this as an STL file. So go to Save As type, click here, click STL, and then click Save. Then click Yes. So now this thing, the cover, is also actually saved as an STL part. Okay. So now we need to 3D print it. We have already discussed, in order to 3D print something, first we will make a 3D model that can be either by making a model from scratch itself by using it from, like using some 3D modeling software like SolidWorks, AutoCAD, even Blender or anything, then we need to convert it into mesh file. Mostly we are using STL to convert STL file format. Then we will use it, then we will slice it, then only we can send that file to our 3D printer. It can either by online, or it can either by like what we call like a pen drive, or any means, depending upon which printer we are using. So currently we are using Form 3BL 3D printer, so we will be using the slicing software of Formlabs. Okay, so for that we can just open software known as Preform is the slicing software that we use for slicing STL files for Formlabs printer. So we will be using Preform software. It's actually the official Formlabs slicing software. So just wait for open it. So this is the user UI for Formlabs slicing software. Once you go to this window, you can select which type of printer you are using for Formlabs. There are different printers like Form 2, Form 3, Form 3L, 3BL and Fuse 1. We are using Form 3BL printer, and since Form 3BL is an SLA printer, we have a different variety of material choices. So here we will be using gray resin to print our part. So just choose the material which is loaded onto your printer. Now we are using gray material. Each material is having its own different properties. So we are selecting gray material and then just click apply. So you will be having your printer and which material is loaded to that printer on your slicing software itself. Now you need to import the model. To import the model, go to File, click Open, and I have saved my STL files in this folder. Okay, so you can see only STL files have been detected by our printer, and here are the options, like you can either select STL, OBJ, or even form file. Form file is a file that is saved from the Preform software itself. So since we have saved it in STL file, we are going to select these two things. So just select both, then click open. So you will be having both of this file here. But you can't print this as it is. You need to orient this. You need to arrange the orientation, give the support. Since it's an SLA printer, we already discussed that SLA printers need supports. So since this is an SLA printer, we need to orient this thing in the best format or best way possible, and then we need to generate support. So in order to orient it, you have like different option here. So this is actually if you need to scale this model. If you need to scale this model, now it's in a particular dimension. If I need to double the size, then I can put 2 here. So it will actually increase its size in X, Y and Z direction by a factor of 2. But now I am going to revert this change. I just need it to be in the usual size. Then you have an orientation option. So orientation means you need to orient this thing in a particular format, so you will be getting the best print quality out of that printer. So I'm going to make this like this, and we know that support will be built from this surface. Okay, if I make our part like this, if I orient our part like this, then supports will be attached to this surface. So since if the supports are here, then we know that once we remove the support, our that particular face won't look that good. So we will try to arrange the model in such a way that support will be come to least visible faces. So I will make it like this. So I'm happy with this orientation for the cover, and for the keychain I will make an orientation like this. So this is also okay. So the support will be coming in base structure. Now I will generate the support. For that you need to go to this menu and then auto generate the surface. So I'm waiting for the support to be generated. So now you can see how our part will be printed. So this is how our supports will be generated, or this is how exactly our part will be printed using our software. And in each software, each license software, the workflow will be different in a little bit manner, but this is the generic form of how you need to do an SLA 3D printing. So I am happy with this. Suppose I need to make two part of this thing, then what will I do I need to import the same model and give an orientation and everything? No, actually I can select this model, head towards this layout option, and here how much duplicate I need to create. Like there is an option for, like, I can create how much duplicate of this shape I want. Now I need to make one more duplicate, so I just select this thing and then just click create option. So you can see one more duplicate is needed. Duplicate is made with the exact supports and everything. If I need to delete it, just click here. You can hide it, or else just click here and press delete option, so it will be gone. So now we created everything, and if we then this is an online printer. Like once you slice everything, you can just pass this file to our printer by online itself. You doesn't need to copy this thing to a pen drive and plug that pen drive into our printer. We can just pass this, or we can just send this thing automatically to our printer. For that, you can go to this option, start a print, and already our printer is selected. I'm going to change it as keychain with cover. Then once you upload the job, it will slice the file and will send this file to our printer. So this is how we will be generally doing a 3D printing on a SLA printer. So once it's uploaded, we need to go to our printer, we need to prime it, means we need to check all the functions, like everything is okay or everything is ready for printing, then we can start the print. So those things we will be seeing in our next lecture. We will be directly going to our printing room, and then we will be seeing we will be having a hands-on experience of how a 3D print can be done with a real 3D printer. So those things we will be checking on our next lecture. So that's for now. Thank you.